This video is brought to you by Colliers Engineering and Design. Colliers Engineering and Design provides multidiscipline engineering, architecture, design, and consulting services to public and private clients. Their comprehensive suite of services offers everything from civil site development to transportation and energy through a nationwide network of offices. Colliers Engineering and Design values their employees and takes pride in their culture. With a focus on professional development and a family atmosphere, some of their offerings are a comprehensive mentorship program, a hybrid work environment, and competitive benefit packages. For more information about how you can join their team, find them on Twitter, Facebook, Instagram, and LinkedIn, or visit their website at colliersengineering.com.
It's not easy for us busy geotechnical engineers to stay up with industry trends while keeping up with our engineering work. Therefore, it's our goal at the Geotechnical Engineering Podcast to help you do just that. We strive to keep our listeners informed on important industry topics and also to educate you on interesting technical topics and trends in the geotechnical world. In this episode of the Geotechnical Engineering Podcast, I'll be talking with Morgan NeSmith, PE, and D.GE. He's an award-winning director of engineering at Berkel Company Contractors Incorporated. And Morgan has his Bachelor of Science in Civil Engineering and a Master of Science in Civil Engineering, both from Georgia Tech, and over 20 years of experience in geotechnical contracting and consulting, including numerous site characterizations and construction projects for remote and offshore facilities in the Middle East, Western Africa, and Asia. We'll be talking to him about some of the recent developments in cast-in-place piles and ground improvement. I'm your host, Jared Green, and I'm excited to be bringing you yet another episode of the Geotechnical Engineering Podcast. And with that, let's jump right into today's episode. Morgan, welcome to the show. How are you doing, man?
Doing great, and it's nice to be here.
Excellent, excellent. Well, I appreciate you being on the show with us today. I know that you're at Geo Congress, so it's good that you're carving out time from Geo Congress to talk with us on the podcast. It's great.
No, I'm really happy to be here. And it's been a good Congress. We're going to fortunately get to talk about some stuff that we've just seen here at the Congress. Ties in nicely with our conversation.
Oh, that's great. Good timing. Good timing. All right, well, let's see. To start it out, can you tell our listeners a little bit more about yourself and what is it that you do on a daily basis?
Sure. So I'm the director of engineering at Berkel. So I handle all of our nationwide. I handle our design group for various Berkel products in the deep foundations and ground improvement, most specifically. So a lot of what comes day to day is projects will come in. We will have soil investigations plus anything from just column loads for buildings that need to be supported or different structures that need to be supported. And we'll take a look and see what we can offer in terms of deep foundations or ground improvement for that project. Sometimes projects already have a foundation type and we see if maybe we can't offer something a little bit different that's again, we call it value engineering, that might be a little bit more efficient, either time-wise or cost-wise. That's a big part of it. And then managing those projects in terms of monitoring installations of the products we're installing, and then testing them and seeing how those are going. Also, because my group works with a lot of engineers, we end up doing a lot of the technical marketing. So there's a lot of talking to local engineers across the country about their regional concerns and certain design techniques we can use for various regions across the country. So it's a good mix of both talking about and promoting different technologies and learning about how different technologies are used across the country, and then also doing the actual engineering work and putting those technologies to work.
That's awesome. That's awesome. Sounds like there's never a dull moment, right?
It can be exciting, as they say, may you live in interesting times, which is both a blessing and a curse, but it's always interesting. Yeah.
Excellent. Excellent. So the listeners on our show vary from, folks that are geotechs and folks that aren't geotechs, and they go from folks that are in school all the way through to professionals that have been doing this for a little bit of time. But it'd be great if you could talk to us a little bit more about some piling technologies, specifically CFA piles, or continuous flight auger piles, and then ACIP piles, or auger cast in place piles. Talk about some of the similarities, differences.
Yeah, sure. So both of those systems are very similar in that they're both rotary systems, single pass and cast in place. So in both technologies, we're rotating a tool into the ground. That tool is a fully flighted auger. Again, in both cases, by single pass, we mean that we drill down typically one time and cast the pile as we withdraw. So there's only one penetration with the tool. That sort of differentiates both between drill shafts or micropiles, where you may drill a little bit and excavate, drill a little bit more and excavate, and then cast the pile once that multiple excavation has been completed down to a certain bearing layer. So again, with both technologies, we're drilling down to a target level one time and then casting the pile as we withdraw. So from an industry standpoint, the industry term is auger cast in place piles. And let's say as far as the DFI auger cast in place pile committee goes, that would cover both what are commonly called auger cast piles, or sometimes auger pressure grouted piles, and CFA piles. And the main difference is the platform that's used to install the piles. So in the 1950s, the auger cast pile was patented in North America, and it was a crane mounted system with a hollow stem auger suspended from a set of swinging leads, or attached to a set of swinging leads that were suspended from a crane. At the same time, in the 1960s, once the fully flighted auger tool had started to be in use in North America, it was also starting to be applied in Europe, but it was being attached to drilling rigs, which were being used at that time to do things like, say, drill steel casing into the ground, or other types of piles that they often refer to as screw piles. So the technology in Europe, when the fully flighted piles were being installed, were, again, since they used a continuous flight, they were called continuous flight auger piles. And the crane mounted systems that we see here and typically in North America were referred to as auger cast in place piles. Now, again, from a industry standard standpoint, like if you go to the DFI's auger cast in place pile manual, that covers both fixed mast platforms and crane supported platforms installing these piles. And I think one of the misnomers that I see being used or being applied recently is that CFA piles are new and necessarily larger than auger cast piles. Both piles can be as small as 12-inch diameter, below which either would be considered a micropile and have a whole different set of standards applied to it. And the larger diameters, I think, as far as I know, up to 4 feet in diameter, 48 inches, have been installed for both auger cast and CFA piles in North America. I think the capability is at this point is at least 5 feet for CFA piles, and is really as large as the imagination and the power packs and gearboxes are available to install auger cast piles. So they're really somewhat similar, but the main difference is the platform from which they're installed. But functionally, if you can install the piles in a given geology, they're both limited by the same code in terms of the amount of stress that you can put on the pile. So there's no real functional difference just in terms of once the pile can be installed. So that's where I think some of the misconception comes in with a CFA being a newer technology. It's been around for decades. It just hasn't really been used traditionally in North America.
Got it. Thank you for that. And as far as depths, I mean, what are you seeing for typical versus the longest you've seen, you know?
Typical, you know, it can vary anywhere from as short as 30 feet to 100 feet, maybe typical, or even 120 feet. But we're, I think, down in South Florida, it's hard to keep up with how deep the auger cast piles are going. And those are crane mounted systems that are now drilling, I think, up to 160 feet deep. I think we installed some 24-inch piles in Hawaii that were about 185 feet deep. And those are a little bit longer than, I think, there are fixed mast. The CFA piles have a limit in terms of the length of the mast, and that may be in the 130 to 140 foot depth range. but they're not too dissimilar. There's a little bit more flexibility with the crane systems in terms of the maximum depth, but they both have their uses and their place in the industry.
Got it. Thank you so much. Yeah, 185 foot. That's pretty long.
That is not an everyday project, right?
For a single pass, right? It's like,
right.
Yikes. All right, cool. Yeah, you were gonna say something.
You have to have a lot of concrete trucks or grout trucks lined up to install a 24-inch 185 foot pile. So
yeah, it's a serious commitment. I mean, once you start, you're not going to stop. So it's like you got to get all those trucks there. All right, cool. And then, with the hot climate too, right? So that's another nuance there.
Absolutely. And what's happened is in the industry in general is that there's just been a push for larger and larger auger cast or CFA piles. Especially in urban areas where sites are limited, the idea of being able to minimize cap sizes from maybe moving away from smaller diameter piles with at least 3D spacings to using a larger, at least 24, but up to 36 or 48-inch diameter pile, and having the grout supply or concrete supply, plus all the additives that have been developed over the last couple of decades that allow us to place these piles and then place intricate steel reinforcing in them, has really opened up that segment of the market to these cast in place systems.
Definitely. Yeah, when again, I work mostly in the Northeast, and whenever I hear about auger cast in place piles, I was always thinking Florida, somewhere south of like Atlanta. And so when I started to see them more in the Northeast, I was like, well, how are you going to do that? Where's the laydown area? We're going to get the trucks, but it can be done. It can be done.
Yeah.
So when we talk about timing of these systems and what's a new system and what's an old system, I want to ask about your opinion on the comeback of the rigid inclusion. And should we call it a comeback? I've heard people say that. I want to know what you think of that.
It is kind of like the term CFA. It's a term that I see used a lot in meaning something that seems to be new and sort of the latest thing. The one good thing I think about it, and it's not just for grouted rigid inclusions, which is what a lot of the term rigid inclusion seems to be meaning when I see it used in reports or specs these days, but different ground improvement systems that have been developed over the last 20 years in the United States and Canada. I mean, and they're extensive. One good thing it's done has refocused the industry away from just pile capacity and sort of a refocus on settlement and sort of the global, or I think Seth Berlman, one of your former guests, used the term holistic approach to support. And I like that definition a lot, because I think in a certain respect, our industry got away from considering settlement as a primary issue, which sounds crazy, but capacity seemed to be the driving force in the deep foundation industry, and moving away from that has been a great thing. To looking at, again, the project requirements in their entirety. Again, it's just sort of a misuse of the term. Rigid inclusions have been around since before structural piles were around. We have been, as a species, I mean, all of us have been shoving things into the ground to try to stiffen that soil since before we ever figured out how to rigidly tie foundations to, or deep foundations to the actual foundation of the structure. So what I often see are the term rigid inclusion when someone means a drilled displacement system that's either grouted or concreted in place. And that's fine, that's great. That I install a lot of them, so I'm happy to see that, but that's not necessarily the only rigid inclusion out there. Anything that is being installed that's stiffer than the surrounding ground, it can densify the surrounding ground. It could just be a stiff element that doesn't really do anything to the surrounding ground between elements. But when you look at the matrix, provides a much stiffer matrix for the overall building foundation. And so it's really just a matter of being specific about what we're trying to accomplish. Do you need a displacement element for a particular application, or are you in very soft soils where you're going to get really the same end product with just an augered grouted element? Or are there environmental factors? Or are you in a soil that will benefit from some vibration or displacement action? So again, I'd like to encourage engineers to really think about what they're trying to achieve, as opposed to just maybe defaulting towards a term that's kind of new or at least being used again more regularly.
Makes sense. And, these systems you're talking about, it's very important to understand what's happening in the ground before it goes in and how the ground will respond after it goes in. And that's going to determine where you are on the spectrum for these systems, right?
Absolutely. And again, I think it's a case of seeing a lot that in a spec, for example, that a rigid inclusion is a drilled displacement element that is grouted in place, and stone columns are a rigid inclusion, rammed aggregate piers. We have all different types of grouted and concreted rigid inclusions. So it is sort of knowing what your ground consists of and what you're trying to achieve at the end result, I think is what's really the most important thing.
Got it. And, for each one of these systems, I guess one of the really important things is just the casting process. And what that means is it relates back to quality control. So as you're gathering information relative to that casting process for, like, let's say a cast in place pile evaluation, there have been a lot of advances in how to enhance that quality of data that's obtained. You talk to us a little bit more about measuring while drilling, or MWD as folks like to call it?
Sure. MWD is the latest term. 20 years ago, I was using the term DAS, data acquisition system based pile design. That sort of morphed into AME, automated monitoring equipment. And I think measuring while drilling really focuses, though, on the engineering side of the data that we're acquiring. And that may be a little bit of a functional difference between how we've been using AME primarily in North America up to this point. So since about the 1990s, and especially with the prevalence of the drill displacement rigs that started to come in the 1990s and early 2000s, data acquisition, however we want to term it, has become a bigger and bigger deal. There have been systems developed to measure various parameters while we're drilling and then while we're casting piles, for both crane mounted systems and, again, for the fixed mast rig systems. And while what we're really using them for today is mainly quality control. So let's say you install a test pile and you are able to measure the torque of the tool, or that's driving the rotation of the tool, the rotation rate, the drilling speed, and the variations in drilling speed through different soil strata. And then once you reach the depth that you want to install the pile, you can then monitor how much grout is placed. And you do that for a test. You test that pile, it passes however we want to define that term. And then we use those automated records that we're collecting for each production pile to ensure some amount of repeatability within certain parameters. We used about the same drill speed to install all the piles. The rotation rates were about the same. Very importantly, the material rates, the concrete or grout that was placed to cast the pile, all these piles varied within certain amounts, but was by and large uniform relatively across the site. So where I think MWE and MWD is going to take us is really more of a focus on the engineering side of the data that we're acquiring while we're drilling, as opposed to just using it as a quality control tool. And that's taking things like the torque, the drill speed, the rotation rate of the tool, and coming up with, it's been called everything from the rig energy to, we use the term internally, installation effort, but it's some measure of the energy that the rig is using to drill the tool, and then how we correlate that with soil data. And then using that both to verify stratigraphy, that each individual pile is being installed through and into and terminating in, but then also verifying the amount of energy that the rig, and it's not too dissimilar from what we kind of do with pile driving in some respects, where you look at hammer energy, but using the rig energy to verify that the same amount of energy or close to it is being used across a variable job site to ensure that the capacity of the pile on the one side of the site is the same as the other side, even though there may be variations in stratigraphy and density or soil state across the site.
Interesting. What about head height? Are you tracking that as well? As far as like when you're lifting, during the lifting operation, making sure you have a sufficient head above the tip of the tool. Is that something that's being tracked as well, or does that have to be kind of back calculated out from the volumes?
That's interesting. What you can do with automated monitoring in terms of quality control right now is follow how much grout is being placed. And we've got everything from flow meters, which are in the line installing through which the grout and concrete are flow through, to actual measurements of pumps where we monitor the stroke of the pump and how much of a stroke, whether it's a full measure of the grout or not, and sending that information. So you can monitor how much grout or concrete is being placed before the tool is ever lifted off the ground, and to build that head height, and then monitor how much grout is placed in each individual increment along the pile as you withdraw the tool. So yes, you can monitor head and each individual increment as the pile is being cast and the tools are being withdrawn.
Awesome. And I guess before we leave here, automated monitoring, and what is the future at MWD?
Again, the future where we're really using automated monitoring right now is quality control. The future, though, is, and this is where MWD comes in, and there's some work being done. The Florida DOT is really leading the way amongst government agencies, and some work being done at the University of Florida, where they're collecting data and really trying to figure out how to use the data we collect while we're drilling to correlate that to what's known about a site because of its in situ data. So for instance, you have a model based on your in situ data, and I just saw a great presentation about how we take in situ data and make 3-dimensional models that you can turn and look at from various directions, and take slices of that 3D model and export that and run that through various engineering programs. And so once we have that model in place, now we should have the ability with these rig penetrations that now, instead of say 20 points across a site, we have 200 to 2,000, however many piles you have, that becomes a data point that you can be using to recalibrate your subsurface model, but also, again, for every pile to ensure that it's in the right zone, the right soil strata, and that it has the right capacity. And I think that's the future, is again, ensuring that the piles are installed both to the correct, but also a little bit more efficiently. Maybe piles don't need to be installed as deeply on one portion of the site, and we can pick that up in real time with this automated monitoring equipment, turning that into measuring, the rig energy going through certain strata, and putting in piles ultimately more efficiently, but with a lot more confidence at the same time.
That's great. And then, if it's a multi-phase development, right? You know more about the parcel now than when you did your initial borings, when you finished.
Absolutely.
Next door. Okay. And then actually, before we leave this area, what do you think about augmented or virtual reality? Can you tie that into what you're doing out there?
That is, I think, what's going to happen we're talking measuring while drilling. We're talking about the very near future. There's no real reason we couldn't be using tools that we currently, the parameters that we're currently measuring while we're advancing these tools, to be doing a lot of the things we've been talking about in real time right now. And we currently have really nice tools to then do a interesting visualization that someone might be able to sit in your office and see a tool or a pile being installed as a tool advances in the 3D model of the stratigraphy. Where augmented or virtual reality comes in is putting on that headset and, again, being in the model and looking at it from any aspect that you want to, and watching in real time, tool being advanced, the data being collected, verifying which soils are being penetrated and how deeply into those bearing stratum that you're getting, and then seeing the rig energy being calculated at the same time. And it's really just a case of really increasing the visualization of what we've been doing for years, but we're now moving away from being on site and thinking, okay, I hear the rig slowing down a little bit, it's working a little bit harder, I know it's getting into a certain layer. Now we're actually being able to see that on a two-dimensional screen in terms of how much energy are we using to penetrate different layers. The next step is, again, just increasing that ability to visualize what's happening in the subsurface by creating these 3D models and being inside the model in a virtual space. And it's not something where we're going to replace people on site. None of this has ever been about that. I think it's the ability to say, if questions do come up on site, to be able to slip into a headset and be able to really take a hard look at what's happening in real time, as opposed to worrying about whether a pile was good 2 weeks later when a report's generated. If there's any question, these things can maybe be answered in a little bit more efficient manner by visualizing this and seeing what's actually happening in the subsurface, and then allowing the project to continue a little more efficiently than trying to have to go back and correct a problem again some number of weeks later.
Got it. And you think this is now, or this is the near future?
Monitoring while drilling is coming. Again, this is work that's already being done at the University of Florida and with the Florida DOT. And to be honest, we've been doing it internally with drilled displacement piles using installation effort for probably 15 to 16 years now. So that's using the engineering side of the parameters that we've been installing is going to be happening in the near future. Whether or not we start slipping into headsets anytime soon and we all get replaced by robots and machine learning, I think we're probably, our jobs are probably safe for some extended period of time.
But don't put the boots away yet, then, is what I'm hearing.
No.
All right, great. Well, before we take our break, what's the final piece of advice you'd like to give to some of the younger listeners out there?
It's kind of two pieces of the same advice. One is the data management is coming, whether we like it or not. I mean, I didn't really get involved in engineering to be a data manager. I kind of got introduced to automated quality and control as a graduate student accidentally, and was interested in it. But that is actually happening. These things are being developed by state agencies, and there are tools being looked at, and it's kind of happening whether we want to or not. So along with the geotechnics, looking at data system management and how we organize and use that data is going to be a skill that you have to develop. At the same time, what I want any engineer to remember is that we are fundamentally not data managers. We're not just there to check a box in a set of specs. And that's why, as great as these tools are going to be, we're never going to be replacing humans at the final end of the day, because ultimately there are judgment calls that need to be made, and we're not just data managers. It's the ability to take these tools and use them to help us make informed decisions and be comfortable with those decisions. That's really what makes us engineers.
Excellent. I think that's a good note to stop on. We're going to pause just a minute, and we're going to close this one out with Morgan on our career factor safety end segment. Stick around.
Before we go on here, I would like to take a minute to recognize our other sponsor for this episode, Menard USA. Menard USA is a specialty ground improvement contractor that works nationally, providing design-build ground improvement solutions at sites with problematic soils. Menard works closely with civil, structural, and geotechnical engineers to minimize foundation costs for wide ranges of soil conditions, structure types, and loading conditions. To learn more about Menard USA or for help on your next project, please visit www.menardusa.com.
All right, welcome back. It's time for our career factor of safety in segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety into your career? Today, of course, we're speaking with Morgan NeSmith, PE, D.GE. Morgan, you've already had a very successful career. And when you look back at your career, is there something that you implemented to give yourself a career factor of safety?
Yeah, I think in thinking about it, it was really being open to the opportunities that presented themselves. I had the opportunity to go overseas, and I ended up working in the Netherlands, but I did not have any intention to go work in the Netherlands. I started working in the Middle East. And when the opportunity presented itself, I thought about it for a little bit, and ultimately, again, I was a younger single person with no real financial obligations, but sort of thought, the worst thing that happens is this really doesn't work out, and I'm 29 and back in the US as opposed to 28 and coming back to the US. Those 5 years ended up being extremely formative, both professionally and personally for me. And I do see occasionally, I think in some younger engineers, a little bit of paralysis with maybe having too much choice or overthinking making the quote wrong choice. And I'm not sure there really is a wrong choice. I would like for engineers to consider everything to be an opportunity, and that it's really hard to make a choice that you really can't steer away from if for some reason it doesn't work out. In much the same way we've been talking about with technology, I certainly did not get involved in geotechnics to become a computer or data acquisition expert. And far from it. I liked geotechnics because I thought things didn't move, and I didn't do very well in my dynamics class, but did very well in statics. But as data acquisitions has become a thing, and I really was tasked with getting involved with certain technologies that really used data acquisition systems as they were developing, just being open to that and really going along with that has just opened up a variety of opportunities since then. So again, I think it's just that openness and not worrying too much about, again, not being able to transition away from something that may not be working out the way you thought it was, that it's really not too late to pivot back towards something else.
And that's super encouraging. When you're first starting out, you don't want to make a mistake. So you spend so much time checking and checking and checking, but you're right. It's like, still take it seriously, but say yes to some things. If somebody gives you an opportunity, say yes. What's the worst that can happen? You come back.
I think what's the worst the worst thing that can happen is often not nearly as bad as you think it is. And the best thing that can happen is often so much better because you never expected it, how that could have turned out in the first place.
You're so right. You're so right. All right. Well, Morgan, thank you so much for coming on, and thank you for sharing all the great insights. You shared some information. I know that this information and the advice is going to be helpful to our listeners. If somebody out there wants to reach out to you, what's the best way for them to find you? You have an email you want to share or social media?
Sure. I'm on LinkedIn and have been taught how to use it very successfully in the last couple of years. So that's an easy way to get in touch with me. But Morgan at berkelcompany.com. And I love talking about deep foundations and data acquisition systems. So I'm happy to do it with anyone. So.
All right, great. Thanks for coming on. We'll make sure to get that information in the show notes. That was great.
Hey, it was great to be here.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, that being episode 47, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all your geotechnical engineering endeavors. Peace.